This video is going to go through Gay-Lussac's law. So as it states at the top, this law gives a relationship between pressure and temperature, and this is going under the assumption that both volume and the amount of gas measured in moles are being held constant. So the relationship here is the gas pressure is directly proportional to the gas temperature. So this can be written as follows. The pressure is directly proportional to the temperature. So what this really means is as my pressure increases, my temperature will increase as well. And vice versa, if my pressure decreases, I will see a decrease in the temperature. So if we look at this in terms of what it actually means in terms of our kinetic molecular theory, thinking about temperature, remember, increase in temperature means that my particles have more energy, they're moving around faster, which means there's going to have more collisions with the side of my container. So if I increase that temperature, I increase the amount of collisions, it makes sense that I'm going to have more pressure exerted on this container that I'm holding the gas within. So mathematically, Gay-Lussac's law can be written as follows. P1 over T1 equals P2 over T2. So remember, as all gas laws, if we're working with temperature, I must be measuring that temperature in degrees kelvins. In terms of my pressure, it doesn't really matter which unit that I'm using as long as my P1 and P2 are both being measured within the same unit. So thinking back to our Boyle's law and pressure variables, gas variables, we looked at the different units that pressure can be measured within. So we have atmospheres, we have kilopascals, we have torr, and we have millimeters of mercury. So as long as they're consistent, it doesn't really matter which one that we're actually using for these questions. So let's look at an example here. Okay, so a 10-liter sample of gas is found to exert a pressure of 97.0 kilopascals at 25 degrees Celsius. What will be the temperature required in degrees Celsius to change the pressure to standard pressure? So we have a couple things going on in this question here. First of all, I have to ask myself, is the volume actually changing in this question? So I don't have a second volume, so I'm really just going to assume that this 10 liters here is just going to be my standard amount. It's not actually changing. So I don't need to look at a V1 and a V2 because, again, it's not changing, it's being held constant. However, I do have a change in my pressure. I'm starting with 97 and I'm going to standard pressure. And it's asking me to find the change in temperature that would be required if I start at 25 degrees Celsius and I want to change it so that my pressure is going to be changing as well. So just like we've done in the past, we first need to organize all of our variables to see what is given to us in the question. So I need to figure out my P1 and T1 as well as my P2 and T2. Okay, thinking about standard pressure here, remember I said it doesn't matter what unit you're actually using for pressure, but because I'm starting with kilopascals for my P1, my P2 has to be kilopascals as well, and the standard pressure in kilopascals is 101.3 kilopascals. If P1 here was given to me in millimeters of mercury, then of course I would use 760 millimeters of mercury in order to keep that unit constant. Okay, and again here I'm looking for T2 to figure out the temperature that would be needed to change that pressure. So keeping in mind here that even though it's asking me for the change in temperature in degrees Celsius, I can't do any of my calculations in degrees Celsius. I'm going to first have to convert it into Kelvin, do my calculations, and then convert back into degrees Celsius in the end. So remember to convert between Celsius to Kelvin, we're adding 273. So my temperature 1, my initial temperature, would be 298 degrees Kelvin, and I'll find my T2 in terms of that Kelvin temperature and then convert. So let's plug this into our equation and solve for my unknown. This one is a little bit more complex to reorganize if we're trying to solve for T2. So I'm going to do this in 2 steps. I'm first going to cross multiply T2 times that, 298 times 101.3, and then I'm going to do a second rearrange to get T2 by itself. Again, if you're going to do this in 1 step, that's totally fine. Just make sure that you show some of your work so that on test I can follow what you're doing. Okay, so if I look at units here, I have kilopascals being crossed out with kilopascals. I'm ending with Kelvin, which again makes sense because I'm looking for temperature amount here. So when I solve for T2, I'm going to plug all this into my calculator. 101.3 times 298 divided by 97.0. I get 311.21 Kelvin. I know I'm carrying more significant digits than required at this point because remember I still need to convert down into degrees Celsius. So in order to go from Kelvin to degrees Celsius, I'm going to subtract 273. So my temperature is really 38.2 degrees Celsius here. So again, if I think about this one in a logical sense, remember we said that the pressure is proportional to the temperature. So if I look back to the starting amounts, I saw that my pressure was increasing going from P1 to P2. So I should see that my temperature is also increasing going from T1 to T2, which I do see here. I started with 25 degrees Celsius and I ended with 38.2 degrees Celsius.